Hey there, I'm Mr. Nicol. I'm going to talk for a little bit here about the Singapore math concrete-pictorial-abstract progression of learning. So a lot of us, when we first learned how to do arithmetic, we were taught it by being like 3 things plus 2 things is 5 things. You might have gotten to pick up and play with, 3, 2, 5, great, hurrah. And then you learn, okay, well, 2 things plus 3 things is 5 things. Like, great, I've learned another thing. And someone might say, oh, well, these are actually, the same relationship between numbers. You're like, are they? It's different. And they're like, oh, well, addition is the commutative property. It's great. Like, oh, I guess I've learned 3 things today. I've learned this problem and that problem and a very fancy word, commutative property. And then I learned, okay, 5 minus 2 equals 3. Like, great, got it. 5, 2, 3 minus equals boom. And then 5 minus 3 equals 2. I'm like, oh, I know where this is going. 2 minus 5 also equals 3. 3 minus 5 also equals 2. And they're like, no. That's not commutative. I'm like, wow, okay. So I learned 4 things, and then a 5th thing, this commutative property, and then I unlearned 2 things. And this is a big day, a lot of things. Singapore likes to step back and say, hey, once you learn algebra, then you can see how this is one problem. This is sort of one thing going on here. And I know many of us had the experience that once we learned algebra, then we looked at arithmetic and be like, oh, all of those last years of math suddenly make sense. This is what we've been doing the whole time. Why didn't we learn algebra first? And it's like, well, it's harder? I don't know. And Singapore says, hey, great, let's learn algebra first. And not by learning algebra, but by understanding that, oh, all of these things are sort of the same thing, and these two are not the same thing, and you'll know why. By hitting really hard first on this concrete stage. Let kids work with things with their hands for a long time. That's, how we learn a lot of things in the world. If there's something that you want to know about, you're like, ooh, that's cool, let me pick that up and look at it. Art galleries have to have do not touch signs on everything because people are like, that's a beautiful piece of art, I want to touch it. So we say for math, great, this is how we figured out how a lot of math works. Let the kids touch it, let them pick it up, figure it out. And you're like, oh, I have my collection of hourglasses and my brother has his collection of hourglasses, and if we decide to pool our resources, I had 3, he had 2, now we have 5. And then he takes his back. Oh, now I have 3, but he puts them back, and then I take mine back, and now he has 2. And you can start seeing how all of these work together. Your 3 and your 2 is 5. Your 2 and your 3 is 5. Your 5, you take away 2, you've got 3 left. You have 5, you take away 3, you have 2 left. And these 2, you take away 5, well, you're running into trouble until you learn about negative numbers, which is a little trickier with tangibles, but just wait till your kids get to a little bit of an older grade. Now, we run into a problem with these physical, tangible things because that's not always practical. Maybe you're doing a problem that involves sheep. Well, we can't readily bring sheep into the classroom. There's a practical and hygiene issue with that. So we say, okay, well, you know how things work with this. You've been working with these physical things for a while. So how about you draw a picture of it? And you can still kind of see how it works. And say, okay, kids love drawing pictures. So you've got your sheep, your 3 sheep, and your brother's 3 sheep. And by his 3 sheep, I mean his 2 sheep, of course. And you decide to combine your fields, put them all together. Hooray, at this mighty herd of sheep that we now have. And you can see, okay, well, 3 sheep, and then his 2 sheep. Let's see, that's 1, 2, 3, 4, 5 sheep. 5 sheep, great. And then same thing, we could have 5 sheep, and you separate them out. And now you've got 3 sheep and 2 sheep. Again, you can sort of figure out all of these problems without having to memorize each one individually. But then you start working with bigger numbers, bigger than 3 and 5 and 2, and it might, be tricky to draw a herd of 752 sheep or a herd of 693 sheep. That will just take a long time and a much larger whiteboard than I have right here, right now. And so we say, okay, well, great, you can still draw a picture. Just imagine all of your sheep are in a box. We've got this box here with all 753. And we know how digits work by now, so we'll just say, okay, well, there's 753 sheep that are my sheep in this box, and then my brother has a herd of sheep that his sheep, he has 692 sheep. Well, that's fewer sheep, so maybe they don't need as big of a box, they don't take up as much space, unless they're smaller sheep, but we don't deal with smaller sheep in this grade. And so we'll make the box a little bit smaller, and we say, okay, well, we've got our 692 sheep. And we can still draw a picture of the problem and figure out the same thing. Oh, well, 753 plus 692, or, oh boy, I just set myself up with a problem that I should be able to do in my head. Let's see, so that would be, we'll take 8 from there, that would be 745 plus 700, that would be 1,445. Let's say it's that. This would be really embarrassing if it's wrong. 1,445 sheep, and all together. And it's again, it's the same thing. We have a pretty picture of it, and you can see all of these relationships between these numbers. So you don't need to learn the 4 different problems that this is representing here, or if you have a word problem, you don't have to work really hard to figure out which one of these is. You just look and see, okay, well, I have these sheep, my brother just took back his sheep, that scoundrel. All right, well, I guess we've got 1,453 minus 692. Let's figure out what this number is over here. So you can draw pictures of it, and we hit that really hard. And then once people are really familiar with the pictures of it, then it's easy to get into the abstract zone. Once this is really comfortable and you can kind of picture this in your head, then you say, okay, well, I don't need to draw that anymore. I can just do it all out over here, which is the end goal of what you want a lot of the time. But a lot of the time, there are interesting discoveries along the way here that will be really helpful in learning later skills. So this is a problem with addition here. You'll see when we talk about bar models, which we'll talk about in another video, about how you can use this understanding addition here to understand multiplication and to understand division. All of the little bits and pieces can build up on having this core foundation of this kind of picture before you move to the abstract phase.